Welcome everyone to this video on how to tackle pick the middle questions in section 3 of UMAT. Just before we get into it, if you have any questions about medicine or UMAT or interviews, or if you'd like any notes or resources or private tutoring, then please get in touch via the address at the bottom of the screen. So I'll begin just by showing you the mapping method, which is just a technique which involves sketching on the side of the page and mapping the different letters as you move across the image. And it's the basis for solving almost all pick the middle questions. So I'll go and demonstrate that to begin with. And once we've got that, we'll then go and do a series of questions based on the number of sides of the shape involved. And I'll show you some of the most common patterns and the configurations that result from those. And I'll just finish up with a few additional questions which didn't quite fit into any of these categories. So the questions we do will sort of be a mix of quite easy to very difficult. But even if you are quite advanced at this and you've had a lot of preparation, there's still a few shortcuts and techniques in here which I think you won't have seen anywhere else. So we'll get started now. So what is the mapping method? Just before I get onto that, I thought I'd throw in a slide just for those of you who are new to section 3 and don't really have a feel for it. So all you need to get from this slide is the idea that if you have a question with a big shape which encloses a small shape which moves, the way to think about the movement of that smaller shape is to look at how it moves along the edges. So in other words, even if, such as in the bottom sequence here, even if it moves from the bottom left to the top right between images, it hasn't sort of teleported across the shape diagonally. It's actually moved 2 spots along the edges. So you always want to think about these sort of questions as the internal shape moving along the edges, either clockwise or anti-clockwise. And if you have a question here with arrows or sticks, likewise it's about a sequential movement clockwise or anti-clockwise. So that's how you think about it in dealing with all section 3 questions. So with that in mind, now on to the mapping method itself. And I thought the best way to demonstrate what it is and how to use it is by doing an example. So imagine you got this question, and this is a pick the middle question. So you have to find the middle picture out of this sequence of 5. So what I would do, and what step 1 always is in this technique, is to sketch in pencil on the side of the exam page whatever the bigger shape in the question is. So in this question, the bigger shape is the square, because it's enclosing the 2 smaller circles. So I would sketch up on the side of the page a square like this, and the grey denotes pencil as opposed from printed ink. And then this square would track the movement of one of the smaller internal shapes. So let's just say that this one tracks the black ball. So given the black ball is there in A, you would put down in the corresponding spot A, and then B in the bottom right, C top right, and just follow on from there. And at this point, as you'll learn from this video hopefully, this pattern is pretty distinct, and it just suggests that the pattern moves one at a time. And in that, so in this case it'd be D. The middle would be D because the sequence would be A, C, D, B, E. Just to illustrate, I'll do another square. So if you were stuck in the exam, you might do another square for the other component. So this is for the black ball, this square on the left, and this one's for the white one. So the same idea. Put the letters in the corresponding spot, and you can see again that it's the same pattern, and D is also in the middle there too. And you can sort of tell after a while of doing these that the pattern when put in order is A, C, D, and then through to B and then E. So just to illustrate this fully, if we now shift the images to being in that order, you'll end up seeing that it's much easier to see the movement of the balls or of any internal shape once everything's put in order. So now if you track across, the black ball moves as we saw it did here, and same for the white, moves in a very orderly fashion. Now, while the mapping method on the slide before is sort of the first go-to point for all pick the middle questions, it's the first thing you should think of doing, there are just a few more little rules and tricks I thought I'd show you which can help from time to time. So the top one there is about the 3-2 rule, which you may be familiar with. It just says that if out of the 5 pictures, 3 have one trait, and then the other 2 pictures have another trait, you could rule out the 2 options. So in other words, in this example below, 3 of the options have a grey background and 2 have a white background. So you could rule out the 2 with the white background in this case. And the reason is that if you put this pattern in order, it would have to go grey background, white, grey, grey to make sense. It would have to alternate. And that would mean that the middle one is grey. So these 2, the white ones, they would be the 2nd and 4th pictures. And one of the middle ones would be the grey ones. So you can rule those 2 out. The second point there is just saying that if of the 5 pictures 2 are the same, neither one can be the middle. And it's sort of just a logistic point that, you know, if one of those was correct, then they'd both be correct, and that would cause all sort of trouble with, you know, which one to select and the marking and all that kind of stuff. So in this example, A and E are the same, so neither could be right. And the bottom point there is just about if a component of the picture seems to disappear momentarily, then it hasn't actually disappeared most likely, it's just hidden behind another part of the picture. So if you see here, the white ball is present in 4 pictures, and it's not visible in the 4th. So the assumption there you have to make is that it hasn't disappeared, it's just hidden behind the black ball. So just keep that in mind. So now we'll just go through each of the shapes one by one. So begin with triangles and then go into squares, pentagons, hexagons, so on. And I'll just demonstrate the main conformations or configurations that can arise when you use the mapping method in each of these, given the common patterns. So we'll begin with triangles. So what we have here is some of the most common patterns I feel they can give you, or indeed all the patterns I feel they could realistically give you, and the conformation of the triangle that would result from the mapping method. So here on the top line we have the pattern which we have basically a pick the middle question where the pattern is one step at a time when it's put in order. So you can see this is an order here. It starts at the top, the black ball, moves one step clockwise to the bottom right, one step clockwise again to the bottom left, and so on. And you can see that in this particular case, this is the triangle that would result from the mapping method. Now, normally with the mapping method, you write down letters instead of dots, but I've just put down dots because I want you to focus on the conformation as a whole, as opposed to the positioning of the letters, because the positioning of the letters will change based on how the pattern is jumbled up to pick the middle question. So basically, don't get too confused with that because it'll all become clearer as we do some examples. But the key point here is to think that if you get this pattern in a triangle, then when you map it, you'll end up with a triangle with 2 groups of 2 and one by itself. And one by itself is the one which is the middle, which is why it's circled, as you can see here when it's placed in order. So it won't always be in the bottom left because the pattern may start in a different spot, but it'll always be the one by itself, the middle. And the nice thing about triangles is that different common patterns such as 2 steps at a time and 2 forward, 1 back, 2 forward, 1 back, alternating, all give the same conformation. 2 groups of 2 and one by itself, which is the middle. So you can see here it's in the bottom right as opposed to the bottom left, but as can be seen here in the middle picture, it's the middle. So key point there, if you have a triangle question and you map it and you get 2 groups of 2 and one by itself, then the middle one is the one by itself. And just one more pattern with triangles, and this is the 1, 2, 3, 4 pattern, which is very common across all different shapes of questions. So what this is if you follow the black ball clockwise again, if it starts in the top, it'll move 1 step down to the bottom right, then it'll move 2 steps, so 1, 2 to the top, and then it'll move 3 steps, so 1, 2, 3 to the top again, and then 1, 2, 3, 4 to the bottom right. So that's why it's called 1, 2, 3, 4. It's 1 step, and then 2, then 3, then 4. It's a pretty common pattern. And the configuration or conformation this gives in the mapping method is shown here. and it's kind of, it follows the same rule, or it appears to be the same as the 3-2 rule, even though it's not technically the same. So you have a group of 3 here in the top, and a group of 2 down the bottom, and the middle one will be one of the top 3, or one of the 3. So again, it's just a case of ruling out the two by themselves, and knowing it's one of those 3, just the same as the 3-2 rule. So now on to an example question, which will hopefully clarify a few things for you if you're a bit confused. We'll just do 2 questions for the triangles because they're both pretty rare and pretty simple. So imagine you got this pick the middle question. So the first thing to do, of course, is the mapping method. So given it's a triangle, sketch down a triangle. And given there are 2 components of the question, you'd probably do 2 triangles, but let's just begin with 1. And we'll use this one to track the movement of the black ball, say. So again, in A, the black ball's in the bottom left, so put A in the bottom left. B, top, so top. C, bottom left, and so on. And so we end up with this configuration which from before we know means that the one by itself is the middle. When you've got 2 groups of 2 and one by itself, the one by itself is the middle, in a triangle that is. So at this point in the real exam, you probably just fill in D and keep going for the sake of, time constraints. But just to illustrate it fully, I'll do another triangle for the white ball. So if we do the same for the white ball, we'll see again that it's the same configuration, 2 groups of 2 and one by itself. And the one by itself is again D, as you'd imagine. So we know from both of these that D is correct. It's that simple. So now we'll just do one more, and it's pretty much the same. So again, because you're dealing with triangles, draw up a triangle, and then track the black ball. So top, bottom right, bottom left, top, bottom left. And in this case, the one by itself is B, so B would be the middle. And again, just to illustrate fully this point, if we did the white ball, you can see A, it's in the bottom right. In B, as I mentioned a few slides before, if you can't see it, it means it's probably hidden. So we'll say it's hidden behind the bottom right, so put it in the bottom right. Likewise in C, hidden behind the bottom left, so bottom left, and then so on, bottom right, bottom left. And this is most likely the 1, 2, 3, 4 method being used here, but we can use the 3-2 rule given that we've got a group of 3 and a group of 2 here. So what this would tell you is just that you can cut out C and E because one of the correct options would be D, B, or A. But this is all a bit superfluous because, as you know from this triangle, the middle one is B, so B. So now onto squares, and I've broken up squares into 2 different categories. One of which is squares with 4 possible spaces, which is when the internal shapes can occupy the corners, so the 4 corners. And the other type of square question is when there are 8 possible spaces, which are each of the corners and the edges. So we'll do that after this. So just begin with squares with 4 possible spaces. So here are the 3 patterns I feel I could give you for 4-space squares. 4-space meaning, of course, the 4 corners. And so again, each of these are moving clockwise and starting in the top left. But even if they started in a different spot, or if they went anti-clockwise, you'd still get the same confirmation, just that the group of 2 in this case would be somewhere different, but it would be the same overall configuration. So key thing to note here is that the pattern you get from, or the configuration you get from the 1 step at a time pattern here, where we have 2 grouped together and then 1 in each of the rest of the corners, is the same as the configuration you get from the 1, 2, 3, 4 pattern, which remember is the one where you go 1 step and then 2 and then 3 and then 4. So you can see that they're the same conformation or configuration, 2 together and then 1 in each of the rest, which can be the source of quite a bit of problems because the middle one, as you can see here, with 1 step at a time, the middle one is opposite the group of 2, whereas with 1, 2, 3, 4 it's adjacent to. But I'll give you a few tips about, and a few shortcuts about how to deal with that in a minute. So that's the 2 key things to notice. And again here, if it's 2 steps at a time, it effectively just moves between 2 opposite corners, and so you get this confirmation here, which you can just use the 3-2 rule on. So this slide is just showing you, well, it's pretty similar to the one before. So this top sequence here is the same as that one there, and this second sequence here is the same as this one here. So I've just brought them together to highlight again how they give the same configuration in the mapping method, because we're going to go through now a few techniques for how to differentiate between those two and how to find the middle. So the first tip is that if ever you have a question with squares and you do the mapping method and get this confirmation, you can immediately rule out the two which are grouped together, so A and D in this case. The reason for that is because you can see in this pattern the one in the middle is opposite the group of two, whereas in this pattern it's one of the ones adjacent to the group of two. So in other words, it's one of the three by themselves rather than the group of two. And so because it's never the group of two, you can rule out those two. In terms of how to then cut down further options from there, you'll need to draw on another component of the question. So for instance, if you then had this box added to the one we had up here, so if you found another component and did the mapping method and came up with this, then you could see here that the 3-2 rule could be used with this one, and that would show that neither C or B could be the middle, because they'd be the second and fourth pictures. So you can rule out C and B. And what that means is, from before, here we can rule out A and D again, and from this one we can rule out C and B, which just leaves you with E. So that's how you sort of break down. You begin by sort of cutting out these two which are together, and then draw on other parts of the picture to further cut down the remaining options. And so just before we get into some actual questions, just two more shortcuts. And this top question looks very similar to the one before. In fact, it's very similar, because in one box we have this confirmation, which we've looked at so much already, and in the other one we've got the 3-2. So this is identical to this question here, except that in this one we ruled out the options by cutting out this group here, the A and the D, and then cutting out this group here on the 3-2 box. And because there were 4 different letters in these two groups, we could cut out 4 options and therefore get to the correct option in the end. So the difference with this one is that if you look at the 2 here, we've got B and C, but if you look at the 2 here in the 3-2 box, C repeats itself again. So the only ones we can rule out are B, C, and D, which leaves us with A and E, which are 2 options, which means you need to find a way of choosing an answer out of those 2. So the shortcut here is that you begin by looking at the 2 grouped together in the 3-2 box. You then find those 2 in the non-3-2 box, so in this one, which are there and there. And then the correct answer is the one which is opposite the letter which is by itself, which is also found in this box here. So in other words, out of C and D, D is the one by itself, and so look opposite D to find A, which is the answer. So that's a good shortcut for those sort of ones. And just finally, this is a favourite of theirs, so this is definitely one to learn. If you get 2 boxes which have this configuration, which is what we've been talking about so much before, first of all, make sure that they are actually different. So to do that, just look at the group of 2 and look at the one opposite, and just make sure that they are different letters, because if you have the same box twice, then you've effectively just got one box. But if they are different, then the correct answer, or the correct letter, is the one which is never found in the group of 2 in either box, so not A or D or E, and is found once opposite the group of 2 and once adjacent to the group of 2. So in this question, we could rule out A, D, and E immediately, but then in terms of B and C, which is still possible, look at B first of all, which is found adjacent to the group of 2 and 1, and adjacent to the group of 2 and another. So that doesn't fit this shortcut. However, C is opposite to the group of 2 and 1, and adjacent to in the other, so C would be correct. So now on to a few questions, and because questions with squares are so much more common than triangles, and indeed every other shape, we'll do a few more than before, and they'll be a bit harder. So here's a typical question, and as per usual, you begin with a mapping method by drawing down a square, and this one will be for tracking the black ball's movement. So again, we just fill it out like so. And at this point, you could rule out D and B because of the 3-2 rule. But then obviously that still leaves A, C, and E. And so in order to cut down those options, we have to do another box on the side and track the white ball. So we just do that now. And again, from our rule before, we know that if you get this configuration, you can rule out the two together. So now we've got C, E, D, and B all ruled out. So the correct answer is A. Now on to another pretty similar question. So same method again. We draw up a box on the side, and this one can, we'll say this one can map the black ball. So again, we'll just map out across the picture. And so at this point, you know that A and B can't be correct because, as we did before, they're grouped together in this configuration, so they're wrong. But we need to know which of C, D, and E are correct. So draw up another box for the white ball. And do the same thing, just map it like so. And this gives the 3-2 rule. So it's a similar one to the one before. However, we can see that because this group of two includes A and E and this one is A and B, A features twice, which means that we can only rule out A, B, and E, and both C and D could still be correct at this point. So if you remember the trick we did before, the correct one, or to find out the correct one, you begin by looking at the two grouped together in the 3-2 box, so A and E, and then you find them in the other box, the one like this. So here they are, A and E, and then you find the one of those two which is not in a group of two, which is E, and the one opposite that is the correct answer. So C is correct. So now on to a slightly different style of question, but even though this looks very different from the ones we did before, you can use the same method, the mapping method, in answering this. So in doing so, just sort of imagine that, that there's a box around each of these images, so a box per image out of the 5 images. And then you simply need to map down where the arrow and then the straight line is pointing. So let's drop a box, as we did before, and we'll use this one to track the arrow bit as opposed to the straight line. So the arrow in this one, in A, is pointing to the bottom right corner. So we'll put an A in there. Here it's pointing top right, so top right. Here back down to bottom right. Here it's top left, and then bottom left. So we get this configuration. And from that already, again, we know that C and A can't be right. But to find out the rest, we'll map the straight line. So again, it's pointing to the top left, bottom right, bottom left, top right, as we go across. And so now we know that D is also incorrect, as well as A and C. So they're out. They're the ones who rule out. But because, unlike the one before, because with this one, there are still 2 options which could be correct, we have to do that shortcut we did before. So if you remember, the shortcut is that the correct answer will never be in a group of 2. So it's down to B or E already. And the correct option will also be opposite the group of 2 in one picture and adjacent to the group of 2 in the other. So if we start with B, B is adjacent to the group of 2 in this picture, and it's adjacent to the group of 2 in this picture too. So it doesn't fit the rule, so it's incorrect, which means E is correct. And if you look at E, in this box it's adjacent to the group of 2, and in this box it's opposite to the group of 2, so that fits. So the answer is E. So we'll keep going with squares, but we'll change our focus from squares where only the corners can be occupied to squares where both the corners and edges can be occupied. So now you can see, the ball can sit here in the middle of the edge, where before we were just looking at the corners. So understandably, when you have corners and edges, so 8 possible spaces in the square available, that creates a very different configuration in the mapping method compared to just 4 spaces. So just going through these one by one, This top one, the one step at a time method or pattern, this gives this configuration where we have the 5 in a row, the middle one of which is the middle, which I think is fairly intuitive. You can imagine this moving like so. So the middle one is that one there in the middle. This second one is basically the same as what we were doing before with this confirmation, which hopefully is familiar to you by now. So that's not really a new one. That should be familiar. This one at the bottom is very important to know. It's the 1, 2, 3, 4 method, which we've gone over before, and you can sort of trace it going clockwise here if you want. So the configuration that gives after the mapping method is done is this one here, where we have 4 together and then 1 by itself. And the middle one, this pattern is so distinct, and this confirmation is so distinct, that if ever you map a square and get 4 together like this and 1 by itself, you can always go, or you should always go, for the one on the edge of the group of 4, which is 2 spots away from the one by itself, as opposed to just 1. So I'll just repeat that because it's pretty important. If you have a square, a question which deals with squares, and you map it out and end up with 4 letters in a row and then 1 by itself, then the correct answer, the middle one, is the one which is on the edge of the group of 4, 2 empty spots away from the one by itself. And so now just a few more common patterns. So up the top here, the 3 steps at a time pattern. This gives a configuration where you've got 2 groups of 2, in the middle of which is a gap, and opposite that gap is a single lone letter usually. So again, it's just 2 groups of 2, gap in the middle, and then 1 across from that gap. So this pattern, or this configuration, is the same for, or this pattern gives that configuration, but this pattern also gives the same configuration. You can see that these two are the same. However, in this one, the middle one is the one by itself, whereas in this one, it's one of the ones which is furthest away from the one by itself. So unfortunately what that means is that if you do the mapping method and then get this sort of pattern, it could be either the one by itself or it could be the 2 furthest away. So there's 3 possible options there. So as with before, we'll do a few examples to show how to differentiate between those. And in the middle here, this 2 steps forward, 1 step back alternation pattern. This gives a very distinct confirmation again, where you'll have kind of all of the mapped letters in a row, and then one of the middle parts of it will have 2 as opposed to 1. And the middle letter, the one that is correct and that you should go for, is the one which is also in the middle but by itself. So that one there, and this pattern can be seen in pentagons and hexagons and octagons. So you'll see it again and again throughout this presentation, but that's a key one to remember too. So now on to some questions, and the technique for solving these are exactly the same as what we did before. So given we're dealing with squares here, draw down a square on the side of the page, and we can say that this one here will track the movement of the black ball. So here we have A, B, C hidden behind the white ball there, D at the top, and then E in the bottom right. So at this point you can kind of see that there are 5 in a row, which is so distinct that you would know that it would be just the 1 step at a time pattern. So it would be going D to A to C to E to B, or vice versa. But either way, the middle is C. So if this is the real exam, at this point you'd probably just fill in option C and then moved on to the next question. But for the sake of illustration, I'll just do another square for the white ball. So the same thing again, just fill it in. And this pattern here, hopefully is familiar to you. It's the one we were talking about before, where we have the 4 grouped together and then the 1 by itself. And if you remember, this is the configuration for the 1, 2, 3, 4 pattern. And what's most important to remember is which one is the middle. And that is the one which is on the end of the big group of 4, which is 2 spots away, 2 empty spots away from the 1 by itself.
So in this case it's C, as we found over here. So in both cases it's C. On to another question now. So same method again, draw up a box and fill in the letters. Now at this point, this configuration again is, I'll go back to it, it's this one here where we have all 5 letters or mapped boxes in a row, and 2 of them sit in one of the middle spots. So we can see that this configuration here is the same as the one we have on this one. And as from before, the middle one is the one which is by itself, but also in the middle of the big group. So C in this case again. But just for illustration, I might do the another box for the white ball. So we'll just quickly do that up. And this configuration could be one of 2 things. It could be this one or that one there, because remember they're the same. And if you recall, this means that the middle one will either be the one by itself or one of the 2 opposite. So if it was this box, it'd be either that one or that one or that one. Or down here it will be this one or that one or that one. So if we go back to the question, this would suggest that the middle would either be E or C or A. But given we already know it's C from this one, just put down C. So now into a slightly different type of question. Although in fact, while it looks different, you can use the same methods in coming to an answer. So what I would do, personally, is imagine a box around each of these pictures like so, and then choose a part of the image which is unique, and then draw an arrow coming off that. So I might choose the outside curve, so like so. And then what I would do is then go from there as I would normally. So on the side of the page, sketch a square, and then track down where the arrow is pointing in each of the pictures. So in A, it's pointing to the bottom left, so put an A down there. B to the bottom, C to the bottom right, D to the top, and E to the left. And so we end up getting this configuration, and it's the same one as the one we did on the slide before, or possibly the one before that. It's the one we have 4 in a row and the one by itself, so it's the 1, 2, 3, 4 pattern. And if you recall, the correct answer, so the middle one, is the one here on the edge of the group of 4, which is 2 empty spots away from the one by itself. So again, it's C. So now the final square question, and this one is slightly more complicated and layered than the ones before, but the same principles apply in solving it. So I'll begin by drawing a square on the page, which will track the black circle. So we'll just do what I've done before and move across each image and track it like so. And the resulting configuration here, if you remember from before, is the one where we've got 2 groups of 2 and the one by itself. And the correct, well, the possible correct answers could be the one by itself, so down here, E, or it could be either of the 2 which are the furthest away from the one by itself. So the correct answers could be E, A, or D, but we can rule out B and C already, so we'll do that. And at this point, to find out which of the remaining 3 is correct, we have to rule out some more options by looking at a different component of the picture. So I'm going to look now at this sort of elongated rectangle, and I'll again map that in the square. So here it's pointing off the top right, so A in the top right, B off the bottom right, so bottom right, and so on. And again, we have the same configuration here on the right as there was on the left, and as before, the possible options are B, E, and D, meaning that both A and C can't be correct. Now we've already ruled out option C, so that's fine, but we also have to rule out option A now because of that, so one more goes down. And of the remaining 2, D and E, we need to look at the 3-2 rule in relation to the background of the shapes. So we can see that 3 have grey backgrounds and 2 have white, and when that's put in order, it'll go grey, white, grey, white, grey. So the middle one will be a grey one, and so we can rule out the white ones, so D in this case. And all this leaves E, which has to be the correct answer. So now on to pentagons and other five-sided shapes, and shapes with 5 possible spaces. Okay, so on to some patterns now for pentagons, and you can see here that the configuration for 1 step at a time is the same as 2 steps at a time, which is the same as 3. They all have 1 in each of the corners of the 5, or 1 in each of the 5 corners of the pentagon. So this is kind of, it's good in the way that you don't have to remember that many, but it does mean that if you ever get this configuration, it's not always as simple as just 1 step at a time. So it could be any of these, which means you need to draw on other components of the picture to find the complete sequence. So those other components could be some of these. So the 1, 2, 3, 4 method gives this configuration here, where you've got 2 adjacent groups of 2, and then opposite there's 1 by itself, which is the middle. So that's kind of fairly common for pick the middle, is that the 1 by itself is often the middle. This one here is the same as before with the square. 2 steps forward, 1 step back. We get this 4 in a row, one group of which has 2, and the middle is the one which is by itself in the middle, next to the group of 2. And just finally, this is a pretty uncommon one. You'd probably be fine not to know this, but I just put it in for reference. It's 2 steps, then 1, then 2, then 1, and it gives this configuration where you've got 2 followed by 3 adjacent ones, at the end one of which is the middle. So now on to the first pentagon question, and this is a bit more difficult than the ones we've done before, because you can see that there are 2 black circles working throughout here. So obviously there are 2 distinct black balls working with different patterns, but we can't tell what those patterns are because they appear the same to us. So the approach is still very much the same. So draw down a pentagon on the side of the page, and then you're sort of forced to map both of these on the same pentagon. So with A, the 2 dots there and there would mean that you'd put A there and there, and then B there and there, and so on until you get this. So this configuration isn't that much help, because if you recall from before, there are 3 different patterns which can give this configuration of 1 in each corner. So it would suggest that the 2 patterns occurring in this question are 2 of those, but we don't know which ones. So the tip I give in this situation is that when questions deal with, or when they give you a question where you can't differentiate between 2 of the components, usually they'll be kind, and one of the patterns for one of the components will be 1 step at a time. So it'll just be simple. It'll be moving from there to there to there to there to there, for example, just 1 step at a time. Now the additional trick with this question is the white ball in the middle, which seems to disappear in these 2. So that's the 3-2 rule again, which means that A and C will be the 2nd and 4th pictures. So what that means with this one is that you're looking for a sequence of 5 working around where A and C are 1 step apart. So basically you have A and then a gap and then C. So looking at the pentagon, there's really only one option for that, which is the A here and the C there, because there's 1 gap in the middle here where there's a D. So that would suggest that the sequence would be like this, where we have a B, then an A, then a D, then a C, then an E. So if we now take those out, we take the B from there to there, the A, the D, the C and the E to give this sequence, and look at the remaining sequence. If we now follow this sequence with the remaining letters, start with a B, and then goes 2 clockwise to A, 2 clockwise to D, 2 clockwise to C, 2 clockwise to E. So that pattern works for both, so D is correct. And now onto a simpler question. So this is much more straightforward. Just map a pentagon like so. So black ball here, map it out. And once again, we got the fairly common one letter in each corner configuration. And as we know from before, that could be any one of three patterns. So we need to drop drop a pentagon for the white ball to get a better idea of what the pattern is. So doing that now, and we see the two groups of two adjacent to one another, the A and the C and the B and the D, and opposite them is the 1E by itself. And if you remember from before, this pattern here is the same as this one here, and we can see from here that the middle one is the one by itself. So going back to the question, that would be E in this case. So this pentagon wouldn't help you that much in the real exam, but this one here would be the clincher, so E. So on to hexagons now, and I think this might be the point where you begin to see some patterns reoccurring. So if we look at one step at a time, again you can see that it's this fairly common and distinct pattern of 5 in a row, the middle one of which is rather intuitively the middle, so that's fairly straightforward. This one here with 2 steps at a time, as is common for a lot of these pick the middle questions, the middle is the one by itself, so that follows that rule, which is fairly easy to remember. Not always true, but often true. And then the 3 steps at a time, because there's 6 sides to the shape, and it's moving 3 and 3 and 3, again and again and again, we just have the 3-2 rule. So the middle will be one of the 3 as opposed to the 2, so one of the 3. And just a few more patterns. These are a bit more complicated. The main problem here is that the configuration you get from the 1, 2, 3, 4 pattern is the same as the one you get from the 2 steps then 1 alternation pattern. You can see both have these two groups of 2 opposite each other, and one of the groups has 2 in them, which is the same for this one here. Now unfortunately, if it's a 1, 2, 3, 4 pattern, the middle answer, or the correct answer as it were, is the 1 opposite the group of 2. Whereas if it's this pattern here, the 2 steps then 1, the correct option will be the 1 which is part of the group of 2. So what that means is that if you have a question with a hexagon and you map it out and get this configuration just by itself, the correct answer could be any one of those 3. It could be the 2, any one of the 2 which are grouped together, or it could be the 1 opposite the 2. So you'll need to do some more working to get past that point and cut out further options. And just finally, the one in the middle here, this is again, as with pentagons and the squares, it's the 2 forward, 1 back alternation pattern, and it gives this rather distinct conformation here with the 4 in a row, and the middle one is the one to the left of, or next to the group of 2, but still in the middle. So they're the key patterns to remember. So let's do some questions now, and again, needless to say, we did the mapping method, so hexagon on the side of the page, and we'll drag the black ball first. So we'll get this result here, and if you recall from before, this pattern of 2 groups of 2 and 1 by itself, if you remember, it's the 1 by itself which is the middle. So in the real exam, if you did this and you got that result from the mapping method, then you just go for A and move on to the next question because of the time constraints. But just to illustrate again, I'll do the hexagon for the white ball. And so we end up with this configuration, and if you remember from before, if you get this, the correct answer could be either one of the ones in the group of 2 or the one opposite the group of 2. So it could be B, C, or A. But obviously we know from before that it's A. So A is correct. So now on to another question, and we'll do the same working again, so hexagon there. And from this we know that, as before, it's either going to be one of the 2 grouped together, or the one opposite the group of 2, so C, A, or D. So B and E are struck out. So now to work out which one it is, we will map the white ball. And this configuration here is the one which is 1 step at a time. So the middle one is D, which fits with this one here. So the correct answer is D. And so now just the final hexagonal question. And even though these aren't hexagons themselves, there are still 6 spaces in which the internal shapes can occupy. So in this sense, it's the same as a hexagon in that the mapping method will give the same results. So this is just to show you that it doesn't have to be a perfect hexagon for you to use these patterns and these methods. So I would probably draw up a replica of this shape for the mapping method. So I would draw up this on the side of the page. And as before, because we can't differentiate between the two components inside, because they're both black circles, we have to map both of them on the one picture. So, as I did before, put down A and A, B and B. The 1C suggests that there are 2 C's in that one spot, so I put down 2 C's, and then the same for the D's and E. So at this point, the trick is to remember that D and E, because of their grey background, could be eliminated due to the 3-2 rule. And furthermore, that then suggests that D and E are the second and fourth pictures. And if you remember before when I said that if you have a question where 2 internal components can't be distinguished between, often the question writers will be kind to you and make one of the patterns one step at a time. So what we're looking for here is a sequence of 5 letters in a row where the second and fourth are D and E. So we need D, then a gap, and then E. And the only place that can happen, as far as I can see, is D here, and then this E here, which suggests a sequence going from A through to C. So if we now write that out, that would give ADBEC, and this would be the remaining configuration. And if you remember from before, this configuration is found both in the 1, 2, 3, 4 method and also in the 2 steps then 1 alternation method. And the middle one is either the 1 in the group of 2 or the 1 by itself opposite the group of 2. So if we go back to the question now, we can see that that means the correct answer would either be A, E, or B. And from this sequence, the middle is B, so that works. So you'd go for B. And the final shape we'll look at is octagons. So once again, because there are more spaces, it becomes more distinct and clear what the pattern is. So one step at a time, again, is just 5 in a row, the middle one of which is the middle. Here with the 2 steps at a time, this is basically, it's kind of like the 8-space square, where we had the square with both the corners and the edges occupied. So the middle one is opposite that. And again here with the 3 steps at a time, as is often the case with pick the middle, the one by itself as opposed to adjacent to another one is the middle. So this one here, which has a gap either side of it, that's the middle. Just a few more patterns now. The 1, 2, 3, 4 method, this is very similar to, again, the 8-space square, because obviously there are 8 spaces. So remember the one before where we had a group of 4 and one by itself, and the middle one was the one on the edge of the group of 4, which has 2 empty spaces between it and one by itself. So that pattern applies again to octagons. The 2 forward, 1 back is again this pattern which we've come to know from pentagons and hexagons. And just finally this one here, that's pretty rare, so I almost wouldn't bother with that, but it could be good to know. Now just a couple of questions on the octagons to help you get familiar with them. So with this question it's fairly straightforward. So we just use the same mapping method we've used throughout the whole video. So sketch an octagon, and then use this one to track the movement of the black ball. So we'll just map it like so. And at this point you've got 5 in a row here, which, as you know from before, is indicative of the 1 step at a time pattern. And so it's so distinct, particularly in larger or shapes with more sides, that you can go for the middle one as being the middle. So in this case, you just probably go for B, and then move on to the next question to save time. So B. But just to illustrate, I'll do an octagon to track the white ball too, so which would give this. And hopefully you're familiar with this pattern because it's the one I've done before, where we have 4 in a row and then the one by itself. And if you recall from before, the middle one is the one which is on the edge of the group of 4, which has 2 empty spaces between it and the one by itself. So again, this is B. So as both octagons give B, the correct answer is B. And now to a more interesting and more complex question. And again, you can see that it's not strictly an octagon, but because there are 8 different spaces, I've classified it as such. So I would, again, map it by sketching the shape used on the side of the page. And as we can't differentiate between the 2 internal components because they're the same color, we're forced to write down both of them. So we'll sketch them down like this. Now at this point, unfortunately, there's no 3-2 rule to help us, or to help guide us pick the first sequence. But if we're looking for a one step at a time pattern, which is my advice in these situations, then I would note that B, A, D, and E all appear in a row by themselves, and they're all different from one another. So if we have a C here, then we'd end up with a sequence of C, B, A, D, E, which would be a good starting point. So if we take that out now, end up with this sequence of C, B, A, D, E, or reverse E, D, A, B, C. We're then left with this configuration here, which is, as again you hopefully know at this point, the 2-step forward, 1-step back alternation pattern, where the one by itself in the middle is the middle one. So in this case it's A, which fits in with this. So A is correct. So just to finish off the video, there are a few types of questions which we haven't covered so far because they're not, they don't involve rotation around a shape. So we'll just go through a few of these quickly to help give you an idea of how to tackle them. So here's the first example of a question which might not be able to be dealt with in the same way. So although it's not a shape where things are rotating in a circle, there's still movement within the shape, so you can still use the mapping method. So draw down, as I've got here, a square with 3 different segments, as is the case in the question, and then map down where the black segment is in each one. So an A is at the top, so at the top, B at the bottom, C in the middle, D2, and then E at the top. So at this point, this sequence may be thinking that it starts at the top, moves down to the bottom, then back up to the top, and 1 down. But it could be a few different things. At this point it's important to see that there's a 3-2 rule happening here, where D and E are the second and fourth pictures. So you can rule those 2 out, and you also know that D and E should be the second and fourth pictures in this sequence here. So if we start at the top, as we thought it might be the case before, it couldn't be E, because that has to be second or fourth, so A has to be the first picture. The second one has to be the D or E, and given it's in this box, has to be D, so we've got AD. Then B has to be for this one, so ADB. Then the fourth picture has to be the other 3-2 rule one, so that's E, and then finish off with C. So ADBEC, which works out pretty well, which means that B is correct. So with these questions, these are the ones where the internal shapes rotate as per usual, but when they reach a certain spot, they change into a different image. So the way to pick up on these questions is that they tend to have, a lot of the internal components stay the same for a lot of the pictures. So for instance, the smiley face is in 4 of these pictures, and the lightning bolt is in 3 of them, and so on. However, they're not all across all the images. There are some differences. So as soon as you see that, you should assume that what's happening is that one picture is being changed, or one of the small pictures is being changed as they move through the sequence when it's put in order. So in terms of how to work these out, I would simply begin with one of the pictures, so we can say A, just to be logical, and then look for the one which has only one internal component different relative to A. So you're looking for this with only one change. And so if we look across, that would appear to be option B, because everything's there except for the arrow is changed for a love heart. So from this point, we just sort of move the sequence along, looking at either side for ones which are most similar to that. So again, if we look at A, we can see that D is also similar to A, and that only one component is different. And then we move off either side of B and D to try and fill out the sequence. So if we look at the sequence in order, which is B, A, D, C, E, you should be able to see that each time only one component changes as you move through each of these. And indeed, if you look carefully, you can see that they actually all rotate clockwise in each one too. So from this sequence, the middle is D, so we can say that D is correct. Now onto a numerical question, which is a form of pick the middle. So if you've seen my section 3 video, you may have seen a very similar question to this. And the idea of these, generally, I mean, it can take many different forms, but generally, if you've got 5 shapes which enclose a series of numbers, within each shape, 2 of the numbers combine to give the other number. So often it's a case of one of the numbers is squared or cubed, and then added to or subtracted from the other number to get the third number. So my tip for this is to look for the biggest number of all. So in this case, that'd be 74, because the bigger the number, the more, well, it's much easier to see which square number or cube number could come from that. So looking at this, that would suggest that that'd be close to 9 squared, which is 81, and 81 minus 7 is 74. So that seems like a pretty good pattern, and your job then is to go across each of the remaining 4 images and see if that same pattern can be applied. So here we have 5 squared minus 4, and it would be 5 squared minus 4 rather than 4 squared plus 5, because we've minused away in this one, so that has to be the same for all 5. And here, 8 squared minus 2, 6 squared minus 3 to give 33, and 7 squared minus 17 to give 32. So once you've got this, you have to write them out like so. And then once you've done that, you have to then order them. So often it's a case of looking down columns to see which one has the pattern in it. And in this case, the first column shows a linear sequence when put in order of 5, 6, 7, 8, 9. And the middle one there is E, so E is the middle. And now on to the final question of the whole presentation. And again, if you've seen my section 3 video, you may be familiar with this type of question and the approach to it. But given it is a type of pick the middle question, I thought I'd throw it in again. So the idea with these questions is that when the 5 pictures are put in order and joined together, they sort of create a nice flowing picture where the lines join one another. So what I do with these is extrapolate the lines on each of the sides, like so. And then I begin with one image, so just for the sake of logic, we'll go for the first one, which is A. And then I look for which image would be the best fit either side of A. So to do that, you look at, for example, the left side of A, where we've got the red at this height and the black at this height. And so now what we're looking for is one of the remaining 4, which has to have the red at the same height and the black at the same height on the right side of their picture to fit in with the left here. So B seems to be the best fit of the 4 because we've got the red at the same height and the black at the same height. So that side would link in with that side, which means that B would be to the left of A. So we build the sequence down at the bottom here, B and A. And then maybe going left of B again, so looking at the left side of B. And of the remaining 3, we're looking for one which has a corresponding height for the black and the red. And it's certainly not D, and it doesn't appear to be E, but C is a pretty good fit. We can see the black and the red at a similar height as would B. So again, this side would fit into this side, which means that C is to the left of B. Now at this point you could keep going and look at the left side of C, but I might go to the right side of A to keep building this way. So if we look at the right side of A, we've got these 2 heights here, And of the remaining D and E, we're looking now for the same height as these two on the left side of those two. So it's not D because they're too high, but it could be A, and in fact that seems like a very good fit. So it seems like the right side of A links into the left side of E, so E is to the right of A, and we keep building. And that just leaves D, and if you look to the right of E, that seems to be a pretty good fit for the left of D, so we'll just put D there. And that's our sequence. And now if you look at this, when we put them together, so first of all C, then we have B, then A, then E, and finally D, you can see how it works. So A is correct. And that's all there is to it. So if you need any notes, resources, or just any questions, then please get in touch. Otherwise, I wish you every success.